Hey guys, physics project. Let me explain this first equation, GPE, gravitational potential energy. See, GPE equals mgh, that's how you find GPE, and each mgh, all three letters stands for, m stands for mass, g stands for force of gravity, and h stands for height off the ground. In this case, mass is 43 kilograms, force of gravity is 9.8, as always, never changes. And height off the ground was 1 meter. Multiply all that together, you get 421.4 joules as the gravitational potential energy from this trial. Now the one on the left is my little sister, is the one you should be looking at. And the top 2 points where she reaches the highest points from front to back are the points where gravitational potential energy is most prominent. And yeah, so yeah, that's it. Oh, and she falls. Yep. That happens. And there she goes. And then here we see my little brother swing to the rescue. Yeah, run. Yeah. And she tries to move her to get her to a hospital, but his attempts seem to not be working. Tries to lift her from her shoulders. Still not working, and sooner or later he, tires out, and nope, there he goes. This illustrates another principle. The work energy principle. This essentially means work done equals change in kinetic energy. So this is to find the net work done. The equation is Ke equals half of mv squared. That's how you find Ke, kinetic energy, to find the work done. So you're finding Ke first. Take the mass, which was 43 kg if you remember before, fill that in for mass, v squared, blah blah blah, boring math. You end up getting 0 because he never moved her in the first place. Yeah. So Ke equals 0 meters per second, so in turn, the change in Ke was 0, so the work done was 0. So here my brother is playing on one of those merry-go-round things that I do not recall the name of, and this is an example of centripetal force. Now it's not the example I'm going to show you, but it's one. The concept of centripetal force that I'm going to show you is the ball on the string, being spun around by the hand. This is a hand, poorly drawn hand, but it's a hand. And the ball is being spun around in a circle. So the things you need to know about centripetal force is it's always in a circular path, demonstrated by the dotted line. The string is perpendicular to the velocity. So this line right here is always going to be perpendicular to the velocity of which the ball is going to be traveling if you let it go. The velocity is always constant. So every time this ball goes around, the velocity will still always be perpendicular to the string. It goes around here, the velocity still goes perpendicular to the string. This is the force being exerted by the hand. That's the force, direction of force, and the force of the ball being exerted by the string is this way. Force on the ball exerted by the string is this way. Yeah. So yeah, I hope you enjoyed that. Thank you. It's very hard to make. Please applaud after the credits. Thank you.